We are still under the part 2 of Rydberg equation. Now, calculate the energy, frequency, and wavelength associated with the transition of electron from n equals to 5 to n equals to 2. Please note, this is a very big confusion to most students. On the part 1 of the video, we were solving question. I said calculate the wavelengths and frequency of the third line in the Perchance series of hydrogen. Now, whenever you hear energy associated with transition, it's a very different formula we're going to use. Different formula all entirely. We're talking about transition here, how elements move from higher energy to lower level, or how they move from lower level to higher energy. And the formula is that changing energy is equals to, which is equals to HF, is equals to B all over 1, the same thing we are doing, square, and 1 all over this, 1 all over n2 square. Now, in some textbooks, you may see they will change this and bring it to this side. If you want to change it, you have to put minus here. So if you want to change this formula, HF is equals to minus B into 1 all over n2 square minus 1 all over n1 square. So it's a minus that separates them. So be careful, please. So that you know, say, this guy said this, and then this is like this. If you want to use this formula, you put minus. If you want to use this formula, there will not be minus. Note it. And note when you use this formula and when to use the Rydberg equation. We use this formula whenever you hear energy associated with transition. You use this formula. And of course, this is a constant. Look at the value here at the board. So I want to use this first one. I want to use this first equation. And so, remember this one, whenever you see change, is E2 is always final minus initial. So this equation can also be written as this: 1 all over n1 square minus 1 all over n square 2. Now, we want to calculate first. Let me calculate the energy. So the change in energy here is 2.179 into 1 all over, and remember I always tell you that your n2 must be greater, so you have 2 square minus 1 all over 5 square, right? So punch that into your calculator very fast, so you need to get your answer. If you should punch it, what you should get as your answer is 4.578. 4.578 times 10 raised to the power of minus 19 joules. Minus 19 joules. Now, this is the energy. But they ask you to calculate the frequency and the wavelength. And I gave you a formula at the part 1. I said that energy is equals to HF. Now, if you want to calculate the frequency is change in energy all over H. Still remember that H is Planck's constant, right? So all you need to do to get your frequency is 4.578 times 10 raised to the power of minus 19 divided, this is a Planck's constant, 6.63 times 10 raised to the power of minus 34. Whatever you get as your answer should be your frequency. The same thing applies here. If you want to get your wavelength, remember I put the formula. I said if changing energy is HF, and if velocity is f lambda, and I said if f is velocity all over lambda, I'll put it here. This equation will change to change in E all over hv all over lambda. So if I want to calculate the wavelength, all you need to do is wavelength is equals to hv all over change in E. So please impute this equation into this, and please drop your answer for me in the comment section about your lambda. What is the answer that you got as your wavelength? Please drop it in the comment section with the SI unit, please. Know the difference between the Rydberg equation and when we are going to use this equation. We're talking about transition of electron. Please know the difference. Thank you very much.